Hello, welcome to Maths with EJD. Here we'll be talking about interval of convergence of power series. And the interval of convergence of a power series is the range of values of the variable x for which the series converges. Okay. Understanding how to find this interval, is crucial in working with power series. Okay, if you really want to enjoy working with power series, you need to know how to find the interval of convergence. By way of reminder, right? A power series, again, I keep doing this. A power series is typically of the form summation from n equals 0 to infinity of an into x minus a raised to power n. So where an are the coefficients, then you have the variable, x is the variable. I think I've been using C all along for the center. So this is C. So this C now is what we call the center. And all of them are really important in the process. Okay. So let's talk about steps to find the interval of convergence. Steps to find the interval of convergence. So number one is to find the radius of convergence. You know, in the last video, we talked about the radius of convergence. So if you have not seen that, you want to go back to it to understand how to find the radius of convergence so you can get a full understanding of this. Of course, we are going to have to talk about that here, right? So, and to do that, you either have to use the ratio test, or root test, to determine the radius of convergence, R. Of course, the ratio test is commonly used. So going forward, I'll just use the ratio test because it is the most commonly used. Okay. So, of course, since we always use the ratio test is most commonly used, so you can calculate the limit, L, which is limit as n approaches infinity for an plus 1 all over an. Okay. And sometimes you have to include the whole, you have to use the whole expression instead of just the coefficient. So the radius of convergence is given by R, which is equal to 1 over L, like that. So the next thing you want to do is to determine the interval. Okay, I want to go coloring here. To determine the interval. So determine the interval. And how do you do that? So first of all, the interval of convergence will be, interval of convergence will be the center C minus the radius of convergence, comma A plus, comma C plus the radius of convergence. Remember, the center from our definition is this. So that's C. So we're referring to C minus R, comma. So it's the interval is that the open is the range C minus R to C plus R, so to speak. That is if R is finite, if R is finite. That is if R is not infinity. So if R is 0, the series only converges, at X is equal to C. That's where X is equal to the center. That is if the radius of convergence is 0, the series only converges at X equals C. And lastly, if R is undefined, if R is infinity, the series converges. The series converges for all X. The series converges for all X. So once R is infinity, the series converges for all X. If R is 0, the series converges only at the point where X is equal to the center. And of course, the interval is the range of C minus R to C plus R. Then the next thing you want to do is to test the endpoints. Number 3, test the endpoints. 3, test the endpoints. So testing the endpoints would mean first you substitute the endpoints. Substitute the endpoints. Of course, the endpoints would be the C minus R and X equals C minus R and X equals C plus R into the original series, to check for convergence, at these points. So a particular endpoint may be convergent while the other one is not. That's the essence of this. So then you can use convergence tests like the P-series test, alternating tests. I think we did alternating tests in the previous video. Alternating series tests or others as appropriate. I'll give examples of this, so there's nothing to worry about. As appropriate. So the final thing to do is to combine results. So everything you have found, combine everything together. So step 4 is combine. Step 4 is to combine results. Combine results. So what that simply means is the final interval of convergence, is either the open interval A minus R, A plus R. I mean, I keep using A. Let's say it's C actually, C minus R from the original definition of power series. C minus R, C plus R, open interval. It can also be the closed interval C minus R, C plus R, or a combination, like, so here now it means this is an open interval, this is a closed interval. So it can also be a combination which is half closed or half open. Something like A minus R, A plus this A thing. That's C minus R, C plus R. So here now, C minus R is not included, but C plus R is included. It can also be C minus R included, whereas C plus R is not included. So this is open below while this is open above. So depending on whether the series converges at the endpoints, like that. Okay, so having talked about the steps to find the interval of convergence, I think to drive the point home, let's go for some examples. Let's take some examples. So the first example is a basic one. Let's say consider the power series summation from n equals 1 to infinity of x raised to power n over n. That is a very simple one. So step one, we just do the ratio tests, like we've already seen. That's the step one. And that simply means we have limits. Okay, the L now, let's compute the L. L is limits as n approaches infinity for this now. So that means we have x raised to power n plus 1 all over n plus 1, okay, divided by x raised to power n over n, which is the same thing as multiplied by n over x raised to power n, So, I mean, we've done this a couple of times. That's why I'm not bothering to go through all the nitty-gritty, because I believe by now it's pretty clear. So that means we have limits as n approaches infinity for x raised to power n times x all over n plus 1 times n all over x raised to power n. So this cancels this. And then we have our L now is like limit as n approaches infinity of, nx all over n plus 1. And what we do at this point is divide each term by n. So we have limit as n tends to infinity for nx over n all over n over n plus 1 over n. And that is L equals limit as n approaches infinity for x at the top, because n cancels out, then 1 under here plus 1 over n. So when we substitute infinity for n, we have x all over 1 plus 1 over infinity. And 1 over infinity is gone, is 0, okay? It goes to 0. So we have L to be absolute value of x over 1, which is absolute value of x. And for this to converge, right? So for this the only condition under which this converges is that this absolute value is less than 1. So we say the series converges, therefore the series converges when absolute value of x is less than 1, which is the same thing as -1 less than x less than 1. That's what this expression it means. -1 is less than x is less than 1. That's the meaning of that. Okay, so we can say therefore R is equal to 1. The radius of convergence is equal to 1. So that's the first step. So we do the ratio test to determine the radius of convergence. Now we have found our R to be 1. Of course, from the conclusions, right, we saw it somewhere that if R, okay, do we have anything? So about the R. Okay, that's for interval now. Okay, I mean, we have R in short. So okay, normally, before I even say this, right? Normally, R is 1 over L, that is 1 over 1, and that is 1. So the limit is 1, so the interval is also, I mean, the radius of convergence is 1. So now that we've got the radius of convergence, let's do step 2. And step 2 is test the endpoints. Okay, determine the interval first. Determine the interval. That's the next step. Determine the interval. Okay, I think that's implied in the expression. So since we already know that absolute value of x, okay, so I can say since the absolute value of x less than 1 implies that we have -1 less than x less than 1, then the interval initially is -1, 1. It's initial because we have to test the endpoints. So we go to step 3 now. Step 3, test the endpoints. Test the endpoints. So we have to test -1 and 1. So test the endpoints in the original expression. So what's the original thing? Summation from n equals 0 to infinity, right? Of xn over n, x raised to power n over n, x raised to power n over n. So we say at x equals 1, we have summation from n equals 0 to infinity of 1 raised to power n all over n. That is summation from n equals 0 to infinity, which is simply 1 over n. So now, because this is 1 over n, right, as n goes to infinity, at x equals 1, the series becomes this, which diverges. It's a harmonic series, which are so we can do one of the tests to check this out. So let's quickly do that test. Does this series really converge? So, and that is determined by the radius of convergence, I believe. We have all those tests, all those done yesterday. So let's quickly do that. So we have L to be limit as n approaches infinity of an plus 1 all over an, and that is limit as n tends to infinity for okay, no, n, I think n is equal to 1, right? That's the expression, the original expression. N equals 1, sorry. N equals 1 to infinity. N equals 1 to infinity. So here we have this, and that is equal to 1 over n plus 1, then divided by 1 over n, which is times n over 1, like this. So we now have limit as n approaches infinity for n over n plus 1. Okay, if you divide each term, limit as n approaches infinity, divide each term by n. So you have n over n is 1, n over n is also 1, then 1 over n is 1 over n. This is 1 over n. So if you put infinity, right? So 1 over infinity is 0. So you have, so put n, the result is simply 1 in short. So this is L equals 1. And for convergence, right? If L is, so L equals 1. If L is equal to, what are those conditions again? The absolute value of the L has got to be less than 1, right? So L has got to be less than 1. So since L is equal to 1, since L is equal to 1, I think it is inconclusive or something. Yeah. So since L is equal to 1, the test is inconclusive. Yeah, the test is inconclusive. Or is it that it diverges? I'm trying to remember now. We have radius of convergence and all that. So the test is inconclusive. But since it is being a harmonic series, it actually diverges. So harmonic series, so it diverges. So in that case now, so we see that at x equals 1, which is this endpoint, that it diverges at that point. So then that's that. Then for the other one, at x equals -1, at x equals -1. So we have summation from n equals 1 to infinity of -1 raised to power n all over n. So, and this is alternating series. So from what we did already before on alternating series, from alternating series tests, or you can also do the test again. From alternating series tests, this converges, because you can see that it's actually, it will be decreasing, so it converges. So the final interval, which is the step 4 now, this is step 3. We're testing the endpoints. So step 4, final interval. Initially the interval was, so we have initial interval, initial interval was -1, 1. But testing the endpoint, this diverges, whereas this converges for alternating series, which we've done before. So we can now say the final interval would be, because this diverges, it means we have to exclude 1. So that means we have -1. So, okay, we have to have yes, -1. -1 converges, right? So we have to exclude whatever diverges. So -1 diverges. So we have, I think it's better to have it this way. So since -1 converges, right? So we can have -1, 1, -1, 1. So 1 does not have to be included because 1 diverges. So we have to get rid of that. So the final interval is, we include -1 and we exclude 1. Okay. So that goes. Let me take one more example and we'll be done for this. So let's take example 2. Example 2. So let's look at this. Example 2. Consider the power series, summation from n equals 0 to infinity of x minus 3 raised to power n all over 2 raised to power n. So again, let's compute the L, which is limit as n approaches infinity for an. So we have an plus 1 all over an. And in this case, that's like L equals limit as n approaches infinity for an plus 1. Anywhere you see n, make it n plus 1. So you have x minus 3 raised to power n plus 1 all over 2 raised to power n plus 1 divided by the original thing, which is times 2 raised to power n all over x minus 3 raised to power n, like this, so that we can tidy things up further and have L to be limit as n approaches infinity for x minus 3 n times x minus 3, from indices, those 2 raised to power n times 2 raised to power 1. So times 2 raised to power n all over x minus 3 n. So this cancels this and this cancels this. So we have L to be limit as n approaches infinity for x minus 3 all over 2. X minus 3 all over 2, that's what we end up having. So we know that for convergence, right? For convergence, you should have L. Okay, there's no n here, right? So this is simply absolute value of x minus 3 over 2. So for convergence, L should be L, which is equal to absolute value of x minus 3 over 2, should be less than 1. Okay, so if you multiply through by 2, that means we have x minus 3 is less than 2. So of course, like I said the other time, this always means -2 is less than x minus 3 is less than 2. If you add 3 to both sides, that's -2 plus 3 less than x minus 3 plus 3 less than 2 plus 3. So this cancels out. So we have minus 2 plus 3 is 1, less than x, less than 5. So this is the initial interval. So this is the initial interval. So therefore, the initial interval is the open interval 1, 5. So 1 and 5 open. So we want to see which one converges, which one diverges. So we have to test the endpoints. So that is step 1. So we've done step 1 or step 1. Step 1. So this is step 1. So let's go to step 2. Test the endpoint. Step 2. Test the endpoints. Test the endpoints. So that's step 2. So we test x for 1. So at x equals 1. So at x equals 1, the expression becomes okay, let's just do that. At x equals 1, we have summation from n equals 0 to infinity of x minus 3, x minus 3. So this is x minus 3n all over 2 raised power n. That's equal to summation from n equals 0 to infinity. So x minus 3, that's 1 minus 3, which is minus 2 raised power n all over 2 raised power n. That's basically what we have. So, of course, that can be tidied up to be summation from n equals 0 to infinity of minus 2 over 2 raised power n, which is summation from n equals 0 to infinity of minus 1 raised power n. So in this case, this series alternates between 1 and minus 1. So the series alternates between 1 and minus 1. So in that case, okay, let's even do the normal convergence test. So we don't just assume. So to test for the convergence, right? So we have L is limits as n approaches infinity for an plus 1 all over an, and that is limit as n approaches infinity for an plus 1. For this will be minus 1 raised power n plus 1 divided by minus 1 raised power n. So that is limit as n approaches infinity for minus 1 raised power n, then minus 1 separately all over minus 1 raised power n. So this cancels out, and we have limits as n approaches infinity for minus 1, which is simply limits as n approaches infinity for 1, and the L at the end of the day is equal to 1. So in that case, we can conclude that it does not converge. So the series diverges because we did not get L less than 1. So the series diverges. It does not converge. So because the series, so we already know we are going to exclude that part which diverges. Okay. So let's take the other endpoint is x equals 1. Don't forget the initial interval is 1, 5. So we have tested 1. Let's test 5. So at x equals 5, the summation is going to be summation from n equals 0 to infinity of x minus 3 raised power n all over 2 raised power n, I believe, is going to be summation from n equals 0 to infinity. 5 minus 3 is 2. So that is 5 minus 3 is 2. So we have 2 raised power n all over 2 raised power n. Yes. And that is summation from n equals 0 to infinity of 1 itself. So, and this diverges because it's always that 1. So whatever we do, that is, we can't see, we don't even have any n to work. So we just see that straight as the limit as n approaches infinity of an plus 1 all over an is simply an plus 1 is 1. An is also 1. So that is always 1. That's 1, which also diverges. So the series also diverges. So the series also diverges. So in this case, none should be included. Both are excluded because they both diverge. So we can now say, therefore, the final interval is 1,5. So the interval remains the same. So so this time around, let's take some practice questions. So let's find the interval of find the interval of convergence for the following. So question 1, summation from n equals 0 to infinity for n factorial all over 3 raised to power n, x raised to power n. That's 1. Then 2, question 2, let's find the interval of convergence for this. We have summation from n equals 1 to infinity of minus 1 raised to power n minus 1, x minus 2 raised to power n, all over n. Then question 3, we have question 3. So that's summation from n equals 1 to infinity of minus 1 raised to power n times x plus 2 raised to power n all over 5 raised to power n. That's another one. Okay. Yeah, so let's do this other one. I think, hasn't this been done? I'm not sure, but if it has been done, just try it still. Summation from n equals 1 to infinity of x raised to power n over n factorial. That's another one. So on that note, we have come to the end of this particular video. If you have not subscribed, be sure to do that. And of course, hit the notification bell so you can get alerted each time a new video is released. Of course, comment, like, and share. Thanks for always stopping by. See you next time. Bye.